All right. So this is gonna be. Let's go ahead. And this is gonna be pH 102, chapter 23, which is gonna be your AC circuits. So we have defined before the resistor, and this was the drawing for resistor was a squiggly line, and we from Ohm's law we saw that where your voltage equals to your IR, that means your V over I, which is going to equal to your resistor. Now we want to define something called your capacitor. Now let's go ahead. First of all, watch this little video that I have on the module. So So in this video, we talked a little bit about capacitors, right? So with capacitor, will be two parallel lines running in through the wire. Now, your capacitance, as we see in the video, is your charge per volt. So how much charge you have per voltage, which if we actually do the units, this is going to be your coulombs per volts. And that's what we call your farad. Now, let's talk about a little about impedance for a little bit. So your impedance. Now, impedance is a very important idea in electronics. Comes from the study of AC analysis. So what is AC analysis? Let me go ahead and define what is AC analysis. So AC analysis, it is where we limit ourselves to inputs, our circuit, that looks like sines or cosine. Basically, because of it, we developed the IV equations. Now, we're gonna look at mainly at your sine inputs. Now the IV equation that we saw with Ohm law. So if we have, let me just actually get a new page over here. So let's say, basically you have, actually before I do that, let me actually go this. So your V equals your IR. Now, we're going to define something called root mean square. And I'm not going to go too much into the definition of that, but this is defined as the square root of the mean square. Square root of the average square, or the mean square. Which in our case, your V root mean square, your voltage for the root mean square, is your V naught divided by your square root of 2. And what we're gonna see in a little bit, your root mean square for I is your disappeared, equals your I naught over square root of 2, which we're gonna go back in definition in a little bit. So your V equals your IR. That means, let me go ahead, your root mean square for your voltage equals your root mean square for the current multiplied by your resistance. Now, going in, let's say you have your capacitor that is connected to the sinusoidal wave voltage. So this is going to be your V naught sine your 2 pi f, or by your distance t. So your VRMS equals your R. Now, your voltage, you got a capacitor in this case. So in this case, your reactance, you can have something called capacitive reactance. So your voltage root mean squared is going to equal to your I root mean squared multiplied by something called your XC. This XC, let me go ahead and get a different color. This is your capacitance, capacitive reactance, which basically tells you how much root mean squared current exist in a capacitor in response to a given root mean square voltage across a capacitor. So capacitor reactance is how much root mean square current exists in a capacitor in a response to a root mean square voltage across the reactor. Now, the capacitive reactance, again, we're taking it because the resistance is going to be in ohms. Okay, now, let me get a different color. Your capacitive reactance is going to equal to 1 over your 2 pi FC. F, let me get a different color on this one. F, that's your frequency, and it's going to be in hertz, like we saw earlier in the semester. Now, C, let me actually get this one over here. C, that's your capacitance. Which again, we defined it over here as your charge per volt, which is going to be your coulombs per voltage, which is your farads. So let's take a little example, shall we? Let's say for example, you have a capacitance of 1.5 microfarads, and your root mean square voltage is 25 volts, and your root mean square current is going to be unknown. So we got a circuit. Let's go ahead and draw it with a capacitor of 1.5 microfarads, and there's going to be again V naught sine 2 pi ft, which is your VRMS, and you're looking for your current. Now, let's say your frequency was 100 hertz. That means your capacitive reactance is going to equal 1 over 2 pi Fc, which is going to equal to be 1 over 2 pi multiplied by your 100 multiplied by your capacitance, which is going to be 1.5 micro times 10 to the negative 6 farads. And we should get 1060 ohms, which means that your root mean square current is going to equal to your VRMS over your capacitive reactance, which is going to equal to 25. This whole 25, already got it. Divided by 1060. So you should get 0.0236 amps. Now let's say we increase the frequency to 5,000 hertz. So let's say, I know there's a good part B. Let's say we turn that to 5,000 hertz. So we increase the frequency a lot. So how much our current right now in this situation would be the root mean square current. So from this one, what we got, that means your capacitive reactance is gonna equal to 1 over 2 pi FC is gonna equal 1 over 2 pi. Now this time is gonna be, instead of 100, what we got? We got 5,000 multiplied by 1.5 times 10 to the negative 6. And we actually should get less resistance, so it'll be 21.2 ohms. That means your root mean square current, which is gonna be, again, your root mean square voltage divided by your capacitive reactance. Actually, let me write this better, that we would not be confused with voltage. That's going to equal to your 25 divided by 21.2 ohms. So you get 1.18 amps. So basically, we increase the frequency, and what happened? Our current increased. Now, let's talk about something called an inductor. Now, an inductor is a coil, a wrapped around coil. That has two terminal electrical component. That stores energy. In a magnetic field. When the current flows through it. So an inductor, let me actually rewrite this better because it did not look good. Is a coil that has two terminal electrical components that stores energy in a magnetic field when current flows through it. So probably you've seen it before. So let's say this is our little wire going in, and when you do, you got a loop of coil wire going through it. Now, let me just go ahead and label some stuff over here. So let's say this is over here, this goes in. So this is a cross-sectional area A. Now, when we get something called N, that's gonna be your number of turns. The distance between them is L, for your length, and your current, let me go ahead and get a different color. Let's say your current flows through over here, and between them, that's your current, between them you get a voltage. Now, we're not gonna go through the whole math of this, but your V over I from Ohm's law is gonna equal to, in this case, your omega L. Your omega, we have defined it before as your angular velocity. which is gonna be your angle divided by your time. Now, the angle that we have is, or the theta that we have, the rotation that we have is gonna be 2 pi for a full rotation, for a full circle, divided. Now, the time, let me actually put this down, what's over here, time. So the time that we're actually dealing with is actually your period. Now, and we define the period as 1 over your frequency. Let me get a different color on this. So this is going to be your period is defined 1 over your frequency. And let me just label this, that's your frequency. So basically, this is going to equal to your 2 pi f. So your root mean square voltage over your current root mean square is going to equal to your 2 pi f multiplied by your length L. Now L is actually defined as your inductance of the inductor. So we can actually find this, your root mean square over I RMS is going to equal, now instead of your capacitive reactance, it's going to be XL, which is going to be your inductive reactance. Which is going to equal to 2 pi f L. Again, L is the inductor of the reactance. So basically we define 3 things. We define, with an inductor, let me actually go ahead, I forgot to actually do this. So when you actually draw it, you go in and you draw a line like that. That's your L over here. So that's your inductor right now over there, and that's how you draw it. So we define 3 things, your inductor, your capacitor, and your resistance. So let's say we add all of them together all the same time. So that's your resistance. Let's say that's your capacitor. And let's say you got an inductor going through it. And this is your V naught sine 2 pi ft. This is your, so what's gonna happen? Let me just see. So when you get a voltage, you're gonna have a voltage across over here is gonna be VR. Across your capacitor, which is gonna be VC, and across the inductor is gonna be VL. Now, that's what we call your RLC circuit. And that's where we actually go back to our impedance. And we're gonna give the impedance a letter Z. Now, the impedance is going to equal to your R squared plus your XL minus. Minus your XC squared. where your root mean square voltage, the one we've been working with, is gonna equal to your root mean square current multiplied by your impedance, Z. Where again, Z is R squared plus XL minus XC squared, which is your capacitive reactance, your inductive reactance minus capacitive reactance squared. So basically, let me go ahead. Your root mean square voltage is gonna equal to your resistor voltage squared plus your inductive minus your capacitance voltage squared, if we actually do the whole thing squared, right? So let me actually write this down over here. So if you actually take a Z squared, is gonna equal to your R squared plus your inductor minus your capacitance squared. So if we're taking VRMS squared, it equals VR squared minus your voltage, get back to black, your voltage across your inductor minus your voltage across the capacitor squared. Now let me actually define this. So your VR, again, there's going to be equals your RMS multiplied by R. Your VL is going to equal to your root mean square for the current multiplied by your inductor, not inductor, your capacitive inductance. And for the one going across the capacitor, VC is going to equal to your I root mean square multiplied by the capacitive reactance. So basically plug it in. Let me get a different color on this. So your V root mean square equals your I root mean square multiplied by square root of your R squared XL minus XC squared. And let me go ahead and define these one more time. So this is going to be 1 over 2 pi F multiplied by the capacitor. This one is going to be 2 pi F multiplied by the inductor L. And we said that the whole thing we're gonna call that into your Z. So your root mean square voltage is gonna equal to your root mean square current multiplied by your Z, which means that your root mean square current is going to equal to your root mean square voltage divided by your impedance, which means it's going to equal to your root mean square. Let's go ahead and just open it up. So that's what we say was. It's right over here. So it'll be R squared plus 2 pi FL minus 1 over 2 pi FC squared. Now, so your root mean square I is going to equal to V root mean squared divided by R squared plus 2 pi FL minus 1 over 2 pi FC, which is capacitance squared. Now the phase angle, let me actually get a different color on this. Between the current and the voltage is going to be called tan theta, which we're not going to go a lot into the mathematics with this, but your tan theta is your inductive voltage minus the capacitive voltage divided by your resistance voltage, which is going to be your XL minus your XC divided by your R. Now, again, solving this, your R, and I'm not going to go into a lot of the math, but your R, your resistance is going to be defined as Z cosine theta, which is the power factor. Let me actually get this. Let me get the red. So cosine theta is actually called the power factor of the circuit. Which means that your power that we defined before as IV is going to equal to your I root mean square multiplied by R. Because again, let me just write this down. V equals IR. Which is going to equal to your root mean square current multiplied instead of R, we can go ahead and put it in. So be Z cosine theta, which is the phase between them. And again, the phase between them, let me go ahead on this one. Is your RLC circuit, and this is your phase between your root mean square for your I and your R. So, and again, we're not going too much into the math of the triangle doing it, but your power is going to equal to your root mean square current multiplied by Z, which is your impedance multiplied by cosine theta. Now, what this is actually telling us is you got your root mean square multiplied by another root mean square current multiplied by Z cosine theta, which we have defined this from the beginning as the root mean square voltage. So let me actually go ahead and write this down. So this is going to equal to your root mean square voltage. So this is going to equal to your I root mean square multiplied by V root mean square multiplied the cosine angle between them. So writing it down, your power, actually we get a different color in this. Your power is going to equal to your I root mean square V root mean square cosine theta, which is your phase between them. So let's say if we have a question of, let's say you get a 2,610 ohm resistor and 1 microfarad capacitor connected in series across a generator of 60 hertz with 120 volts. Determine the power delivered to the circuit. So let's go ahead and solve this question. So your resistance, we said it was how much? 2610 ohms. Your capacitance is 1 times 10 negative 6 farads. And it was connected at 60 hertz with voltage of 120 volts. And we want to see the power delivered to the circuit. Well, your reactive impedance for the capacitance is going to equal to, well, before we do that, let me go ahead and solve the power. For your power, that's going to equal your V squared R over R squared plus XC squared, which is going to equal to 120 squared multiplied by your resistance, which is 2610, divided by your 2610 squared, plus we need this little fellow, that capacitive reactance. So our capacitive reactance XC is going to equal to 1 over 2 pi FC, which is going to equal to 1 over 2 pi multiplied by your 60 for your frequency, multiplied by your capacitance of 1 microfarad. So we should get 2,650 ohms. So basically, we're gonna have to put 2,650 ohms square over here, and we should get 2.71 watts. All right, let's do another question, shall we? Actually, let me go ahead and let's copy this question. See if we can actually paste it right over. Then we would have the question down there. Let's do another question, shall we? So let me actually go ahead and copy this question down. So the cover 7 RC circuit and the current is 0.669 at 49 watts. What is the voltage of the generator? So for this question, let's go ahead and write down our knowns. Now you know your power is your 49 watts, and your current is 0.669. 0.669 amps. And you want to determine the voltage, root mean square voltage. RMS over here. So your voltage, in this case, your power equals your RMS current, root mean square voltage multiplied by cosine the angle between them, which that means your root mean square voltage is gonna equal to your power divided by your root mean square current multiplied by cosine angle between them. So we're gonna go ahead and say the cosine between them is 0. This is gonna go to 1. So basically what you're gonna have is your power over your root mean square current, which is gonna be your 49 divided by your 0.669. So that should equal to 73.2 volts. Great, let's do one more example. All right, let's go ahead and do one more example. Go ahead and do this one. So what do we have in this question? We have our inductor, which is 10 times 10 negative 3 henries, and has a volts of 14 volts, root mean squared, and your frequency is 860 hertz. And you want the peak value of the current, which is your main current. And again, we defined before your root mean squared is whatever current we have divided by the peak value of current divided by square root of 2. So in order to find that, we need to find the root mean square for the current. So actually, let me write this down. Hold on a second. Write this down. So your I naught, the one we're trying to find, is your root mean square multiplied by your square root of 2. Now, in order for us to find the root mean square current, your root mean square current is going to equal to your voltage divided by RMS divided by your XL. But we don't have XL. Well, I guess we need to find XL. So, which is your inductive capacitance. Inductive reactance. So, your XL, we defined it as 1 over 2 pi FL, which is going to equal to 2 pi multiplied by your frequency, which is 860 hertz, multiplied by your 10 millihenries. 10 times 10 to the negative 3 Henry, so that should equal to we got 54 ohms. So we got this one is equal to 54 ohms, which means that our root mean square current is gonna equal to your 14 divided by your 54. So that's gonna equal to 0.26 ohms, which means that the peak valley current is gonna equal to your 0.26 ohms. Ohms, it's supposed to be amps, I'm sorry. So your 0.26 amp multiplied by your square root of 2, which is gonna equal to your 0.37 amps. And that should conclude chapter 23 for physics 102. If you have any questions, go ahead and email me at abunaem@uah.edu, or you can call me or text me at 256-348-1480. Thank you.